going to be one of the easiest ones. If u is a differentiable function of x, then d dx e to the u is e to the u du dx, or simply u prime times e to the u. So let's take a couple examples here. So on this one here, if I identify u as being x cubed, then u prime is equal to 3x squared. And my derivative, dy dx, is equal to u prime times e to the u. So we come over here and go, well, then we get dy dx equals u prime, which is 3x squared, e to the x cubed. Nothing more. There it is. Okay, next one. U equals x plus x squared. U prime is 1 plus 2x. And our derivative is u prime times e to the u. So we come over here, dy dx equals u prime, 1 plus 2x, e to the x plus x squared. Okay, next one, remember x to the negative 1, or square root of x is just x to the 1/2 power, so this is going to be e to the x to the 1/2 power. So we can go u equals x to the 1/2 power, so u prime is 1/2 x to the negative 1/2. Rewritten, it is 1 over 2 square root of x. Y prime is u prime times e to the u. So we come over here, dy dx equals 1 over 2 square root of x times e to the u, or e to the square root of x. So in other words, dy dx is equal to e to the square root of x over 2 square root of x. There's your derivative. Okay, so let's look at the next one that they're bringing up. If u is differentiable function of x and for a greater than 0 and a is not equal to 1, because if a is 1, 1 to any power is still 1, d dx is equal to a to the u is a to the u natural log of a du dx, or u prime times a to the u times natural log of a. This is where I can always point out that e to the x is the same idea. It would be u prime times e to the u natural log of e, because that's the a value, but natural log of e is equal to 1. That's why it doesn't have it, because it's a special case. We can just consider that it's a special case. So if you can start with this going, oh, it's the same as e to the u, it's just I have to take the natural log of whatever the base is. So that might help you out on some of these. So on this one here, example of derivatives of a to the x, at what point on the graph of the function y equals 2t minus 3 does the tangent line have a slope of 21? So we'll come over here. When we do the derivative, we're going to have y prime equals whatever the derivative of 2 to the t is minus 0. So we don't have to worry about this. I don't want you guys going, what happened there? Derivative of 3 is 0. So I have a is 2, and u is t, so u prime is 1. And then our derivative becomes u prime times a to the u times the natural log of a. So we come over here going y prime equals u prime, which is 1, times a to the u, which is 2 to the t times the natural log of 2. And we want to know when the value is going to be 21. So 21 equals 2 to the t natural log of 2. So on this one here, to go quickly through the problem, I'm going to even change the color pen, is what we're going to do is we're going to natural log both sides. Now this is where some of you guys are going, oh crap, I don't know my trig. Some of you are going to go, oh crap, I don't know my exponential functions either. There's a lot of rules of exponentials, but we're going to be using like a basic 2 or 3 of them. And so as we go through, we'll just go through the reminders. But this is no different than any other algebra problem. Whatever you do to the left-hand side, you do to the right-hand side. So if I was squaring one side, I'd square the other. Take the natural log of one side, I take the natural log of the other. So now I have the natural log of 21 equals the natural log of 2 to the t times natural log of 2. And I apologize, I should have taken this, moved this guy to be at first. Actually, we're going to do that. You guys are going to go, oh, come on. I apologize for this one. Just as I started writing in red, I realized what I had done. So let me erase this for a second. And I wanted the 21 equals 2 to the t natural log of 2. And I'm trying to isolate the t, so I want to move this guy away. So I'm going to divide by natural log of 2. This is what I should have done to begin with. Now I have 21 over the natural log of 2 equals 2 to the t power. So we'll go back to blue now. Now I'm going to do the natural log of each side. So I have natural log of 21 over natural log of 2 equals the natural log of 2 to the t power. And here is one of the things that we are going to be doing that you'll see over and over and over again. When you have the natural log, now natural log is just an exponent, because the question here would be e to what power gives me 2 to the t power. Actually, it's e to this power would give me this. So what you can do is take your exponent and move it down forward, because if you raise a power to a power, you just multiply the two powers. So now I have natural log of 21 over natural log of 2 equaling t natural log of 2. And we're almost down to dividing this by natural log of 2, divide this whole thing by natural log of 2, and you get t is equal to the natural log of 21 over natural log of 2 over the natural log of 2. Now, we can always use a calculator to estimate this value, but this is going to be just fine the way it is. Whatever this value is. Actually, let's go ahead and do this so that we have that calculator idea of, oh, what's my calculator? Oh, there it is. Okay, so if we put this one in, I have the natural log of 21 over the natural log of 2 divided by the natural log of 2. And that gives us 4.9210. And you must give the correct decimals up to the first three decimal places. If you don't want to worry about rounding, throw the fourth decimal place on. They're not going to worry about it. So when is it? When is the slope 21? When t equals 4.92. There you go. In all reality, I would even prefer this over this one here, unless you had to do more with it. Okay, let's try another one. At what point on the graph of y equals 3 to the x plus 1 is the tangent line parallel to y equals 5x minus 1? Parallel means that they have the exact same slope. So I'm asking, when is y prime equal to 5? So it's the same idea as before. This one, my a value is 3. My u value is x. So u prime is going to be 1. So I have y prime equals, so my u prime is 1, and then 3 to the x, natural log of 3. There's my derivative plus 0, because the derivative of 1 is 0. And I need this guy to be equal to 5. So I need to know, when is 3 to the x, natural log of 3, equal to 5. So first, let's take care of the natural log of 3 by dividing both sides. So I have 3 to the x equals 5 over natural log of 3. And I'm going to purposely change colors here. I'm going to natural log both sides. So I have natural log of 3 to the x equals natural log of 5 over natural log of 3. Use my power rule. So I have x natural log of 3 equals the natural log of 5 over the natural log of 3, and then divide both sides by natural log of 3. So x is equal to the natural log of 5 over natural log of 3 divided by the natural log of 3. So we can throw this into the calculator again. So I have the natural log of 5 over the natural log of 3 divided by the natural log of 3, which gives us, in this case, 1.3793. So you can either give the 1.3793 or 1.379. Doesn't matter. Correct to 3 decimal places. That's the biggest thing you have to remember, is when you write problems out, they have to be correct to 3 decimal places. Okay, let's see what we have next. Okay, so the next one is for just the natural log of x, just like e to the x. This is one of the simpler ones. If u is a differential function of x and u is greater than 0, then the derivative of natural log of u is 1 over u du dx, or simply u prime over u. So let's say a little bit easier on this one. So on this one here, we look at this, we go, well, u is equal to 3x squared. So u prime is 6x. And our derivative y prime is u prime over u. So y prime equals 6x over 3x squared. And yes, you should clean it up a little bit. 6 over 3 is 2. And x over x squared is going to leave you with x. And of course, this is as long as x is greater than 0, because we cannot have a 0. That's knowing your domain for natural logs. It cannot be, this guy here cannot be 0. It has to be something larger than this. So even here, we can claim as long as x is greater than 0. And there you have it. Some of these you're going to find to be really, really easy, some not so much so. Like the last one we'll use kind of sort of a bit. E to the x, absolutely. Natural log of x, absolutely. You'll see these quite often. Now this one here, I want to point out to you, I had to type it this way because my computer wouldn't let me do it the way it showed. But originally this problem was like this. But just like trig, it's a natural log squared of x. So you're squaring the natural log value, not the x value. So I just rewrote it like this. So we'll have to do a chain rule kind of thing here. So u is going to be natural log of x. So u prime, 1 over x. And yes, we could have done the inside-outside rule. S of u equals u squared. So S prime of u is 2u, and this is your derivative. So dy dx equals u prime, which is 1 over x, times 2u, or 2 natural log of x. So dy dx equals, I just realized what I did. That should be 1 over, because it's u prime over u. See, that's why you write that, u prime over u. So this is my derivative. So I'm going to get 1 over 2x natural log of x. Okay, so I did that one wrong. This was the derivative for up here. I need to multiply these two together. This is chain rule. See, this is why you have to make sure that you're paying attention to what you're doing. Some of you guys are going, what the heck are you doing? No, I started it right, and then I second guessed myself thinking I was doing it wrong. But I'm doing the chain rule, not the u prime part. The u prime part, the natural log was here. And that's gave me the 1 over x. So the x goes in the denominator, and then the 2 natural log of x goes on top. 2 natural log of x goes on top. There's your derivative. Okay, so this is, I make a mistake. This is where you can look at going, oh, okay, so, nobody is clear from making these mistakes. So I want to make sure you guys are sure of that. Okay, I'm watching the time, 18 minutes. I think this is the last example in this section. If it's not, we're going to make it the last example. It is. Okay, this one here is a little bit more difficult than it looks. The line with the slope m passes through the origin and is tangent to the graph y equals natural log of x. What is the value of m? So this is what we're looking for, but they gave us absolutely nothing. They gave us no point. Well, let's go ahead and start with the derivative. The derivative for natural log of x, y prime, is equal to 1 over x, which is equal to our slope. We have to find out what the value of x is. Well, that's okay. In algebra, we learned how to find the value of x. We learned it by doing y2 minus y1 over x2 minus x1. Well, we already know one of the points. They told us one of the points is the origin. We went, okay, cool. One of the points is the origin. The question is, where on this graph does it touch? Now, believe it or not, we actually do we can assign a point. How's that? We can assign a point because we know that if x is a, then our answer is going to be natural log of a. But we can use the same idea here. If we have x, then this is going to be natural log of x. So really kind of already have information here. Because m, my y value is natural log of x minus 0 over x minus 0. I know, you guys go, really? Okay. So I have now my slope is the natural log of x over x, which is equal to this guy over here, which is equal to 1 over x. So since I have natural log of x over x equals 1 over x, we can ignore these two. I know that my natural log of x equals 1. And so if we do raise each of these to a power of e, there's another thing that you guys will have to know, be able to do. And the rule of e to the natural log of x is simply x. And so x is equal to e. So my slope, now we can come in here, we know what slope is. So y prime equals 1 over x, which is equal to my slope, that x equals e. So I'm just wrapping it all up now. X equals e, so my slope is 1 over e. There's my slope. That's all they asked you for. What was the value of m? M is 1 over e. Okay, so that does take care of day 1, 21 minutes, a little bit longer than we want, but I think I also kind of, messed up a little bit. You stop for the calculator a little bit. Okay, I'll stop talking. All right, day 2, coming soon.